In this video, I'm going to tell you guys a little bit about quantified selves. Basically, quantified selves are a way to measure and analyze data that you've been recording about yourself. It can be anything over a period of time, a week, a month, and you can record it at different intervals, hourly, weekly, etc. And this data can be anything. It can be your mood, it can be your blood oxygen levels, your blood pressure, your heartbeat, how many steps you've taken, and it doesn't even have to be related to health. It can be almost about anything at all. Now, for the purposes of this video, we're going to be looking at the step count of an individual, of yourself, and I'm going to be monitoring my step count over a week-long period from June 27th to July 3rd of 2016. So to do this, you can do this using any type of application on your mobile phone. A lot of them monitor step counts, and some examples include just the health app on the iPhone, or you can get your own step counter app. Even the Fitbit, which has come into popularity recently, monitors step count, and it has its own app. And the way you want to analyze this data is by exporting it as a CSV file or some sort of file where you can analyze the data in MATLAB to see the different trends of your walking over the course of this week-long period that I'm looking at. And so I've already done that, but just for a way to get you guys started, once you have your app downloaded, there's different ways you can export it, and I'll leave that to you, but the method I used was just using the health app on my iPhone to track my data, and then I used an app called QS-Axis. And what QS-Axis let me do is just export the data to my email, where I just dragged it into my working directory in MATLAB where I could use it to analyze. And QS-Axis is pretty simple. You just click on the different, it has a list of different parameters, and all you have to do is click on the parameter you want, turn it on, and then create a table which you can email to yourself. And you can do this in hourly intervals or day intervals. So I've done that, and as you can see here on the side, you have the CSV file, and I named it health data. And I can open it in Excel to show you guys how it looks. So here's the data in Excel. It gives you the start time and the finish time and the step count. And basically the start time and finish time have an interval of 1 hour. And as I scroll down, you can see the various step counts throughout my week-long period at, spaced out in hourly intervals. So to analyze this data, first we have to obviously get this data into MATLAB. And the first step I usually follow is just to clear everything in the command window in the workspace and close any figures that I have, just to make sure that there's no confusion and there's no overriding of variables or using old variables for the new code that I'll be running. So to do this, I first got all the CSV files in my current working directory, and this is the line that I used to do that. So I can go ahead and first I'll run step 1. So I'll just run this section. And now I have in my workspace a structure of files, and that structure of files is only one by one because in my working directory I only have one CSV file, and that happens to be my step count CSV file, and it's called health data. Now step 2, after I've got the CSV file into MATLAB, I want to get the step data out of my CSV file, right? So an interesting property of a lot of Excel files, a lot of CSV files is that, and in conjunction with MATLAB, is that you can read them as a table. So I use this command, read table, with files, the first file in files, and there's only one file in files, as I mentioned earlier. So I'm going to read files in, and now I have the day data, and we can go ahead and look at it here. And as you can see, it's a table. There's a start, finish, and my step count here, and it looks really similar to my Excel data. And this is going to be particularly useful to us when we go ahead and analyze it. After importing our day data, we can change all these dates into date time variables, which are easier to manipulate and look at for our quantified self, to look at our own step data over the period of a week. So to do this, use the date time function, and I'm only going to be converting date times out of my start column in my day data table. And I'm only going to do this because the finish time doesn't really matter, as I can use the start time for each individual hourly interval from midnight all the way to 11 o'clock. So I'm going to go ahead and run this date time. And if we go ahead and go look at it, you can see that it gets all the dates, and it looks pretty similar, but it's no longer a string, but rather a date time variable. And you can do some different things that are pretty cool with the date time variable. The first of which is get the weekday out. So I forgot to mention this, but in this quantified self, what I was doing is looking at my walking for hourly intervals and seeing if it was different for each day of the week. Specifically, I wanted to compare the weekdays with the weekend. And to use the date time variable and get the weekday it corresponds to for each variable within that date time matrix, use the function weekday. So I'll go ahead and use this, and you can see I have two outputs. And when we go back to the weekday, we're going to get different values out. It's a 168 by 3, and you can see that the weekday portion is the name of the certain day of the week, and WDN, as I've labeled it, would correspond to a number. And if we click on it here, you can see it starts with the number 7, and if we click on weekday, you can see that first value is Saturday, meaning that Saturday corresponds to the number 7, and then Sunday corresponds to the number 1. So we know that our weekend days are 1 and 7. After doing this, I'm not sure that I actually ended up using this, but just as an aside, you can actually make dates into vectors, which kind of helps with the analysis, and I'll show it to you guys. So DVS, I use the date vec function, and takes the input of my date time variable, and DVS, if you look at it, gives you a vector, a matrix of different values. So here we have the year, then we have the month, then we have the day, the hour, the minute, and the second, which can be useful for particular assortment of applications, depending on what you want to do with the data you're taking in. And lastly, just to make it a little easier on myself, I extracted all the step data over the course of the week-long period. And I did this by accessing the column step in my day data table and assigning it to a steps variable. So the first thing I wanted to do was just extract let me go back and run this, making sure I ran everything here. So the first thing I wanted to do was just plot my weekday data. So Monday through Friday, I wanted to plot all of my steps per hour. So the first thing I did was type a for loop from I equals 2 to 6. And this corresponds to that weekday number we talked about earlier, where Monday through Friday corresponds for the numbers 2 through 6. And to do this, I found as I'm looping through, we'll just take the first run through as an example. When I loop through the first time, I set my variable j equal to all the positions where this weekday number is equal to 2. And we can go and look at this weekday number, and we scroll down. So this corresponds to all the spots in our data file that correspond to the day of Monday. And obviously there would be 24 spots because there's 24 hours in a day, and we're only looking at a week-long period. So after doing this, after finding all the places where it is Monday, you can go ahead and we can find a plot, or we can make a plot where we plot 0 to 23 on our x-axis as our hour of the day, because we're considering midnight as 0 as our time start variable did. If we can go back to that and look at that really quick. As you can see at the top, midnight corresponds to the first 0 hour, but it would be the first hour of the day. And we plot this with steps j comma colon, and the colon means all columns. You could have put a 1 here because the steps data is only one column, but the j tells us all the rows where our data occurs for the day of Monday. And I just made this blue, and then I made a hold on function right here, a hold on command, to go through the different days of the week. So I go from 2, 3, 4, 5, 6, and by running through it, we can see the difference in our graph. And let me just run it for you and show you what it looks like here. So evaluate it. So right here, this is what we get. We get a bunch of blue lines because I plotted all the weekdays as blue lines. And you can see a spike here, and I'll explain that to you guys later. But remember, this is only the weekday, so Monday through Friday. So we want to look at the weekends, right? So as I said earlier, Saturday corresponds to a day of 7, a day number of 7, and Sunday obviously corresponds to a day number of 1. And we're basically following the same process where we find all the locations in our day number vector here where the value is equal to 1 or 7 depending on which time we're running through the loop. The first time it's 1. So when we run through it the first time, we find all the 1s, then we plot from 0 to 23 corresponding to the hours of the day. And then we plot the steps on our y-axis where j just tells us where in our steps matrix all our step counts are located for that particular day. And this works because of the fact that when I took in the start data and when I took in the steps data, it has the same number of rows, right? Our day data is 168 by 3. So if I look at the first column, which is the starts, or if I look at the third column, which are the steps, they'll have the same number of rows. So the rows correspond to the starts, and the starts correspond to certain number of day numbers for depending on which day of the week it is. So I can go ahead and run this for you too. And when we look at it, you see figure 1 right here. And in looking at figure 1, oops, you can't see figure 1. Apologize for that. One moment, please. So I'll show you the figure at the end, but essentially after that all I did was, have my X labels, my Y labels, the title, the X limit, and I limited it from the certain parameter I put in here from 0 to 23. But I also, as you may have noticed, labeled my plots as objects H1 and H2. And I did this because when I'm going to my legend, I only wanted to label a weekday and a weekend. And this would have been very difficult if I considered 7 different lines. So the last run through, 6, which was Friday, which happens to be a weekday, was labeled as H1, and the last run through this, which is Saturday, which is 7, was labeled as H2. So I just used H1, H2 as a vector here, and then label them as weekday and weekend. So I can go ahead and run this whole thing for you guys, and a plot should appear. And let me try to bring it up here. So as you can see the plot, and in looking at this plot, you can see that my steps taken are on the y-axis and the hour of the day is on the x-axis, and there's a weekday and a weekend right here. So when I'm looking at this data, it's important to be able to draw conclusions, right? The conclusions from the data and make sense of the data. And we see some peaks here. We see on Friday, I see this blue line. Well, you can't see that it's Friday, but I know that it's Friday. A peak here, and you see peaks on the weekends right here. And, to make sense of this makes sense to me at least, because I know that I go for walks with my family on the weekends. So, these spikes in data on the weekends make sense. And on the weekdays, you see a larger value right here, which would represent the time that I'm active, going to school, making a commute, whereas on weekends, I'm staying at home more. So this is what I can take out of my hourly step interval data over the course of a week-long period. And I hope this tutorial showed you guys a little bit about how to use quantified selves and an introduction to quantified selves to look at data and hopefully analyze it to make sense of what you're seeing. And as stated in the beginning, you can use quantified selves for almost anything. It doesn't have to be, the steps taken. It doesn't have to be health. It can be, how much you read each day. You could catalog it and then look at your trends. And, you can use this simple analysis, this simple way to monitor your daily activities and then look at it at a future time to figure out what's happening within your life. And that's basically the whole point of doing quantified self. So I hope you enjoyed this video. Thank you. And thank you. Best of luck.